Transcendental numbers are a curious thing. In one sense, most real numbers are transcendental, but in another sense, it's pretty difficult to show that a given real number is transcendental. So if we take the two most popular and commonly known and famous transcendental numbers, pi and e, and we combine them in common ways, is the result a transcendental number? For example, what about pi plus e? Do you think that's transcendental? What about pi times e? What about e to the power of pi? Or pi to the power of e? Well, despite the fact that pi and e are transcendental, I only know that e to the power of pi is transcendental. I have no idea if pi plus e, pi times e, or pi to the power of e are transcendental numbers. In fact, I don't even know if pi plus e, pi times e, or pi to the power of e are irrational numbers. Can you believe that? Pi and e, two transcendental numbers, we don't know if pi plus e is irrational. Isn't that crazy? Well, we do know that at least one of these two has to be transcendental. So by way of contradiction, let's suppose that both e times pi and e plus pi are algebraic numbers. Alright, now since these numbers are algebraic, we can do stuff to them and it will remain algebraic. We can do algebraic stuff. So pi plus e is algebraic, so pi plus e squared is algebraic, right? Okay, that's algebraic, and since pi times e is algebraic, 4 times pi times e is algebraic. And if I take an algebraic and I subtract an algebraic, that's algebraic. Okay, but what is this equal to? Well, this is equal to pi squared plus 2 pi e plus e squared minus 4 pi e. And what is that? That is pi squared minus 2 pi e plus e squared. And what is that? That is pi minus e squared. That is algebraic. But if pi minus e squared is algebraic, then its square root, pi minus e, is algebraic. That's not good, man. Pi minus e is algebraic, and pi plus e is algebraic. So, 1/2 times pi plus e, an algebraic, plus pi minus e, an algebraic, is 1/2 of 2 pi, also known as pi, is algebraic. That's a contradiction because pi is transcendental. Let's walk through that again. We're supposing by way of contradiction that both pi times e and pi plus e are algebraic numbers. Since those two numbers are algebraic, I can say that the square of pi plus e is also algebraic, and when I subtract 4 times pi times e, which is also algebraic, that whole thing is algebraic. But this is all equal to pi minus e squared, so that's algebraic. So the square root, pi minus e, is algebraic. But when I add pi plus e to pi minus e, I get 2 pi, and if I take half of that, I get pi. That's also algebraic, so that's a contradiction. So this shows that it is not the case that both of these numbers are algebraic, so that means at least one of them is transcendental. Alright, now keep in mind, we do not know that pi times e is transcendental, and we don't know that pi plus e is transcendental. We just know that at least one of them has to be transcendental. So the only one of these numbers that we've mentioned that I know is transcendental is e to the power of pi. This follows from Euler's identity combined with a theorem called Gelfond-Schneider theorem. This says that if you have an algebraic number that's not 0 or 1 and you raise it to the power of an irrational number, the result is a transcendental number. For example, 2 to the power of the square root of 2 is transcendental. So if we combine this with Euler's identity, we can get the result that e to the power of pi is transcendental. I'll give you a second to attempt to do that on your own and leave your solution in the comments down below. You know the drill. Let's get started. Alright, so we're going to use Euler's identity and Gelfond-Schneider to show that e to the power of pi is transcendental. Okay, so by Euler's identity, we know that e to the power of pi times I is -1. And since e is positive, we could write this as e to the pi to the I equals -1. Now, Gelfond-Schneider says that if you take an algebraic number, not 0 or 1, and raise it to the power of an irrational number, you get a transcendental number. Now, -1 is not transcendental, so it must be that either e to the pi is not algebraic or I is not irrational. Now, I is irrational. It is a complex number that is not equal to a ratio of integers, so by process of elimination, it must be that e to the pi is not algebraic. In other words, e to the pi is transcendental. So that shows that e to the pi is transcendental. So to recap, we have no damn idea if pi to the e is transcendental or irrational. At least I don't know. We don't know if pi times e or e plus pi is transcendental. We just know at least one of them is. But we do know that e to the power of pi is transcendental by Euler's identity combined with the Gelfond-Schneider theorem. So yeah, a lot of open questions here. It's difficult to show that some random real number is transcendental. That's why these are still open questions. We do not know if e plus pi is transcendental or even irrational. But I hope you guys enjoyed this video and found it interesting. That's going to do it for this one. I'll see you next time.